The next solid design principle we will be looking at is interface segregation principle, which states that instead of having one interface containing many functionalities, we should have many small interfaces, each containing a specific functionality. Here's an example. Assume that we have one large interface, interface 1, that contains 5 methods. But assume that we could classify these methods into two categories. Methods 1 to 3 is about behavior 1, and methods 4 and 5 is about behavior 2. So the interface segregation principle tells us that instead of putting all these methods with two different behaviors into one large interface, we should split it into two different interfaces, each interface containing the methods related to one specific behavior. So in this example, methods 1 to 3 are about behavior 1, so they should be put into their own interface, interface 2, and methods 4 and 5 define a behavior 2 that's a separate behavior than behavior 1. So we should split them and put them into its own separate interface. Let's call it interface 3. Here's a concrete example where we have one large interface called printer tasks that has 3 methods in it. So print, scan, and fax. And assume that we have 3 concrete printers all in one printer that can print, scan, and fax. Mid-level printer that can print and scan but not fax, and an economic printer that can print but not scan and fax. So when we have a large interface like this, every printer must implement the interface and override all methods. But because each printer can only do certain tasks, they still have to override the other methods and say that I'm not able to do that. And here is an implementation for it. Here is our large printer tasks interface with the 3 methods. All-in-one printer implements the printer tasks method and overrides every abstract method in here and say that I can do all of these. Mid-level printer also implements printer tasks and says I can print and scan but not fax. An economic printer implements the printer tasks and says I can print but I cannot scan and fax. Here is the actual code. This is the interface printer tasks with the 3 methods, and these are my concrete printers. So I'm instantiating one object from each printer and calling print, scan, and fax. Let's look at the output. So as you can see, all-in-one printer can print, scan, and fax. Mid-level printer can print and scan, but not fax. And economic printer can print, but not scan or fax. So this large interface containing these 3 methods violates the interface segregation principle. If you think about it, printing, scanning, and faxing are 3 different behaviors. We should not put them into a single interface. And if we do that, like in this example, then every printer that implements the printer tasks interface still have to provide, an implementation for every abstract method in here. And if the printer does not support any of these functionalities or behaviors, it should say, I'm not able to do that. So that's what we are observing in here. So economic printers still have to provide them interface, implementation for scanning and faxing, although it doesn't support them. And you have to do this because every functionality is put into one large interface. So what the interface segregation principle tells us is that instead of putting all these 3 different behaviors into one interface, we should split them into 3 different interfaces, each containing one specific behavior. So like I'm now splitting this into 3 interfaces. The first one is can print, that only contains the print method. Can scan, that contains the scan method, and can fax, that contains the fax method. So now if I am the all-in-one printer, I am going to implement all of these interfaces and provide implementation for each of these methods. If I am the mid-level printer, I'm going to implement can print and can fax and provide implementation for print and scan. And if I'm the economic printer, I will only implement can print and provide an implementation for a print. And here is that implementation. So now we have 3 interfaces, small interfaces, each containing one specific behavior. All-in-one printer implements all of these interfaces. Mid-level printer implements print and scan. An economic printer only implements can print and only supplies an implementation for the print method. Here is the actual code. We now have 3 interfaces, each containing one specific behavior. And each printer only implements the behavior that they support. So all-in-one printer supports everything. So it implements all interfaces and provides an implementation for everything. But economic printer only supports printing, so it only implements the can print interface and provides an implementation for the print method. So if I now instantiate objects from these printers, I can only make a call to the behavior that this printer supports. Let's run the code. You can see that the first printer supports everything, mid-level printer supports only printing and scanning, and the last one supports only printing. So integrate segregation principle now let us split this large interface into smaller interfaces, each containing only one specific behavior, and the concrete classes only implemented those behaviors that they supported. So they did not now have to provide implementation for the behaviors that they did not have to support. And this is a much cleaner implementation compared to the previous version. And this is the recommended way you should design your interfaces.